score this one. Okay, so once again, in the module 3 stuff, I find it useful to kind of label what it is that we know. So right here, P out, a linear motor reaches a velocity, that's u, and it reaches it, so we could also call that, like, it doesn't label on the formula sheet, but it's like a u steady state. That's what it finally reaches. The maximum B field is 3T, that's B. We have a 450 voltage source. They actually call it VB because it's the voltage in the B field, I think is why the linear motor says VB, but it's on the equation sheet is VB. And this one is eta, and remember eta is efficiency, P out over P in. We're asked to find the required rail resistance, so that's R resistance, source current I, and bar length L. So those are the three things that we're going to be asked to find. So if we look at the equation sheet, kind of like even with the transformers or the other DC motors, if I come over here to my equation sheet on the DC side, here's my linear motor, and everything that I need is in this box. The only one that I said isn't is that efficiency formula right there, but I have it written down. So the terms that I know B, I'm being asked to find I know my power out. I can easily get with my efficiency, my power in, right? And so I know my voltage, what else? I know my U here, right? And one of the ones I'm being asked to find, I'm being asked to find L, I'm being asked to find R, I'm being asked to find I, right? So you don't have to go through the equation sheet and just label like check boxes. That's not the point of it, but I'm just showing that we have several knowns, we have several unknowns. So thinking about which ones do I need to solve for, and grabbing those equations off the formula sheet is a good place to start. So we'll do part A is find, actually, and maybe, I guess they asked for all three of them at the same time, because you can almost see, based off what I just showed, is that I can quickly get the I, VB, I, right? Because if I do those and I say that efficiency is P out over P in is P out divided by efficiency. P out is 10 kilowatts, efficiency 0.95, and I get 10.526 kilowatts. That makes sense. P in is greater than P out, which it must always be. I can rearrange for I, and I have P in divided by VB. P in, 10.526 kilowatts divided by 450 volts. I get 23.39 amps. The next one is R that I'm going to solve for, and that's pretty quick to look at. It's the only one where R is, right? And is that the best way to do it? Yeah. That's fine, because now that I have I can find E induced. And if I find E induced, I have VB, I can solve for R. And then once I also have E induced, I have U, I have B. Once I have E induced, I can get L. So kind of which one you do next is up to you. But we can do VB minus E induced equals IR. We'll rearrange that to where we're going to solve for R is equal to VB minus E induced over I. E induced, we said the power out was equal to E induced I. And so E induced equals P out divided by I, P out 10 kilowatts divided by 23.39, and I get 427.5 volts. That also makes sense. My E induced is less than my VB. 450 minus 427.5 that we just solved for, plugs in up top, 23.39. And my R comes out to 0.962 ohms. So R is 962 milliohms. The last part, we'll do in orange, is the bar length. And we have E induced equals U BL, rearranged for L E induced over U B. E induced, we had down below for 27.5 volts. The U is the velocity, 100 kilometers per hour. And the B is Tesla. That's 3 Tesla. And the one thing that I need to put here, and I think I would probably ask, or I would give you a hint for this, is that in order to put this in, because we don't have the unit for Tesla broken down, so this needs to be in meters per second. I'm in kilometers per hour. I need to put it in meters per second. So that's the one thing on this that I think we should give you, either what is in Tesla or say that the units of U, but if you just remember it's in meters per second, 100 kilometers per hour. And I can do the railroad tracks. 1 kilometer is 1,000 meters, and 1 hour is 3,600 seconds. If you need to do 60 times 60, right, for 60 minutes in an hour, 60 seconds in a minute, that would also be fine. But at meters per second comes out to 27.7 meters per second. So here, this needs to be 27.7 meters per second. And then once I do that, I get 5.12 meters.